Alright guys, welcome back. We're going to be solving another question from dynamics, and we have this car that is traveling at a constant speed of 100 kilometer per hour and on the level portion of the road. So we're talking about this part. And after that, it's going to go through a 6% incline, and the car decelerate at a constant rate of g sine of theta. And obviously in this part, when the car is going up, it's going to slow down. So the question is asking us to determine the speed of the car on two conditions. First, 10 seconds after passing the point A, and second, when the S is 100 meters. So looking at this, we'll see first of all the initial velocity that we have is kilometer per hour, so we need to do a unit conversion because all the units are in meter and seconds, so we should be consistent with our units. So let's just do that first. Initial velocity 100 kilometer per hour, and we need to get rid of kilometer first, so we need meter, kilometer. We know 1 kilometer is 1000 meter. That's how we get rid of kilometer. And also hour per second. 1 hour 60 seconds. 60 times 6, 3600. Let's just show it this, so that way we can get rid of the hour too. And at the end of this, we basically need to divide 100 by 3.6, and let's see what we get. 300 divided by 3.6, that's gonna give us 127.8 meter per second. So that's our initial velocity. Also, we know that the acceleration of actually the deceleration of the car is g sine of theta, and we're going to consider negative value in here because it's deceleration, and our g we're going to consider because all of units are SI units, so 9.81. So 9.81 times sine of theta, which from the question we should be able to find theta. So our theta in here would be we know tangent of theta would be 0.6%, so 0.06. So theta would be tangent inverse of 0.06. So let's just figure out the acceleration. So negative 9.81 times sine of, so this is going to be our acceleration, 0.588 meter per second squared. So that's our acceleration. So for the A part, the question, we have 10 seconds, and we're going with the constant acceleration, which is the value that we found in here. So we can use the formulas that we have for that. So we know the velocity at our ending point would be initial velocity plus AT, or acceleration times time. So we figure out, so the question is asking us after 10 seconds. So our t is 10 seconds. Initial velocity was what we found in here, 27.8 plus our a, which was negative 0.588 times 10 seconds. And that's going to give us the velocity after 10 seconds. So 27.8 negative 0.588 times 10. This is going to be 21.9 meter per second. That's the answer for the A part. And for the B part, the question is asking for the distance S, which we know, we know that the S is 100 meters. So we have to find the velocity after that. And for that, we're going to use our formula v squared minus v0 squared is equal to 2a s minus s0. S0 is 0. We're just going to consider our starting point here. So that's going to be our direction, and this is our 0. So 0, our s is 100. Velocity at the end is what we are trying to figure out. Initial velocity was 27.8 negative 2 times the acceleration, 0.588 times 100. So our V squared would be 27.8 squared minus 2 times 0.588 times 100. That's going to be 655.24, and our V would be the square root of this value. So square root of answer, that's going to give us 25.6 meter per second. And the final answer for this question. Everything was clear. Let me know if you guys have any questions. You guys take care. I'll see you in the next video. Have a good one.